there are three vectors operating in this activity, and for a maximum effect, for a maximum area of F, these three vectors should be perpendicular to each other. All these three vectors lie perpendicular with each other, just like the Cartesian coordinates, that is, two are in one plane, other in the perpendicular to the plane. Similar to that, this geometry of direction, perpendicular, three vectors direction which are perpendicular to each other, this geometry of orientation, this geometry can have any possible orientation in space, keeping all of them in the perpendicular direction. It can have any orientation, but keeping all of them in perpendicular direction. Whichever orientation, we need to understand the direction of the three vectors. Whatever may be the orientation of this geometry in the space, we need to understand what would be the direction of the three vectors. That we understood by a rule. In physics, there are a set of rules based on the experimental observations. Here we have two rules. One is Fleming's left hand rule, and the other is right hand palm rule. Any one of them can be used to realize the direction of the vectors. Any one we can use. Now let me illustrate this rule as well as that rule. For this Fleming's left hand rule, we have to use our left hand. Hold for this, the illustration here, we have to hold our left hand like this by stretching first three fingers in perpendicular with each other, like this. All these fingers. As you know, this finger is thumb, this is forefinger, this is middle finger, already indicated here. So you have to head your hand like this, so that this finger lie, what is that, parallel to this one. This line is parallel to this line. This line parallel to this line, because it is perpendicular to the both. So indication here, this will indicate the magnetic force, action of magnetic force, indication of what is that, magnetic vector, indication of velocity vector. Here velocity vector. Velocity vector is same as direction of the positive charge, remember, or direction of electric current. Velocity vector, it is same as direction of positive charge or direction of current. Both are same, all are same. So this finger indicates the velocity vector, it indicates the magnetic field vector, it indicates the force which is acted on the charge, this direction. Look at this. Very good. If you know vectors of any two direction, the direction of other vector can be identified by holding our, that is, hand in such a way, given vectors like these two vectors in parallel, see that other vector, the direction you can identify like this. This is Fleming's left hand rule. What is right hand palm rule? For the right hand palm rule, we use right hand like this. Stretch our right hand in such a fashion like this. All the fingers, four fingers in one direction. This finger in the other direction perpendicular to these fingers, and the palm facing in one direction like this. Stretch your right hand like this, palm with this palm. This is what diagram indicates. These fingers indicate the direction of the magnetic field. This finger indicates the velocity vector. And magnetic field vector, what would be the magnetic field vector? It is a direction facing, that is the direction of the palm facing. Direction is this. It is facing like this. The force act like this. If there is velocity vector, if there is a magnetic field vector, then the force push like this. So direction of the force like this. Palm direction is the force direction. Any one of the rule can be used to identify the direction of the force. Magnetic force, if you know other two directions. Let me illustrate this. Assume that here on a plane of sheet, or notice that on the board like this, there are three vectors which are perpendicular. How do you symbolize? The symbols are used to show the direction of the vectors. The symbols are arrow mark, here arrow mark, line on the plane, and one more symbol like this, one more symbol like this. That means this symbolizes that vector is perpendicular to the plane but inward. It implies the vector is perpendicular to the plane but outward. That is two arrow marks and the symbol like this. Three vectors, indication of the direction of three vectors. These questions like this are important in objective type of questions. So in the question, if you have given this, look at this, we have given the direction of this and direction of this. This may not be given because written like this. Assume that this direction is not mentioned. Only this and this are mentioned on the paper. How do you identify this? Use any one of the rule, either Fleming's left hand rule or right hand rule. Let me apply Fleming's left hand rule. Hold the finger with all the three fingers stretching in perpendicular direction. Holding like this. See that these two are given. What is this? Magnetic field is perpendicular to board, inward direction. Now this is magnetic field, that is velocity vector. You have to turn my hand, what is that? So that these two are coinciding with the direction. What is the way we can turn like this? This is the way we can. If I turn my hand like this, shows that that is a direction. What is the direction of the field? Inward direction, perpendicular. Velocity direction like this. If that is the case, you see that if these two directions, what would be the direction of the force? This must be the direction of the force. That is why direction of force is indicated. So this is how the force direction is identified using left hand rule. Using palm rule. Here, stretch your palm like this. Fingers like this, fingers like this. And turn my palm so that this line, what is that? Magnetic field line, and these lines are coinciding with these directions. This is one direction, other directions. So if I, what is that? Look at this. That is the one. If I turn my hand like this, stretching legs and turn my hand like this will give the direction of B, perpendicular inward to the plane. This will indicate the direction of velocity vector. Then how do you find the velocity or this force vector? It should be the what is the direction of the face. It is this is the direction. So palm direction is the force direction. It is the direction of palm. So force acting like this in upward direction. This is how direction is identified using this. Either this or this is to identify the direction of the force. So with all this I will explain. We are using right hand palm rule. This is one. Here assume that it is not given direction. The direction only this and this is. Stretch your right hand palm like this and like this, and velocity vector. So turn your hand so that this line coincides with the velocity vector, indicates the velocity vector same direction. This line coincides with the field vector. So this is the way of stretching in accordance with the given directions. This direction is not assumed that the direction is not given. How do you find this F direction? Your direction of F is what is a palm direction. That is a palm direction. Movement of palm. So this is how direction of the force for these two vectors identified. What about this? In the same rule, I'll put this side and this. Stretch your right hand palm like this, and direction is outward, perpendicular and outward. This would be the what is that? I have to turn my palm like this in such a way that this direction coincides with velocity and this direction coincides with this. That is field vector perpendicular to board, away from outward. That is the direction. And what would be the force on this charge? Here facing, palm face out upward. So that is the direction we identified like this. Here vector B, vector velocity. Stretch the palm so that it will like this. That is the alignment. And turn my palm like this so that this will coincide with the velocity and this will coincide, B will coincide with this direction like this, direction outward like this. And how do you find the force vector? Force vector here, their palm is facing this direction. Therefore, force must be in this direction for these two vectors. This is how this direction is found. But is written, but it is found. What about this problem number 5? Look at this force. Now, the right hand palm stretch like this, right angle to each other, and rotate the palm like this. Represent the direction of this. This represents the direction of this. And what would be the direction of the force with this? It is facing outward. Look at that. Force is outward force. That is why the symbol says that the force on this is outward identified. What about this? Here, same. Here it is one. I am rotating my hand like this, showing the direction of the field, direction of the velocity, and what would be the direction of the force facing towards this. Outward force, again outward force. And the final one, direction of magnetic field, the same palm, right hand palm, stretch and and rotate so that this in alignment with B, this in alignment with B. This is the one possible rotation. This my hand like this shows the direction of the magnetic field and velocity vector. What must be the direction of the force? Here facing inward, palm facing, that is the direction of the force. This is force perpendicular inward. This is all these what is that examples are written only positive charge. Only for positive charge. Fleming's left hand rule and palm rule. If the charge is negative, what would be the force direction of the force? For positive charge, one direction. Negative charge, as you understood, is opposite direction. Opposite means if it is negative charge, the force, what is that? It is downward here, opposite direction. That is just reverse the direction force if it is negative charge. So the rule is set for positive charge. For here, if it is negative, the force direction is reversing in the opposite direction like this. If this is negative, the force instead of this here downward. Here changes the direction like this. Like this, you have direction inverted if the charge changes. So that is the one example I have given here using the form force only. I am keeping my what is that? The palm stretching like this. Velocity vector is coinciding and magnetic field vector is coinciding with this line, and the palm is directing like this. There is a force for positive charge, outward force, but negative charge it may be opposite, that is inward force. For minus q, the force becomes inward, perpendicular inward. So this is how using it is easy to understand the direction using right hand palm, because on this either plus q or minus q, given the direction of any two vectors, other directions can be identified. This is all. So keeping in mind the rules, we can answer easily the objective type only. This is very important for the objective questions. This we have completed. Thank you.